Howdy, guys. Welcome to the show. Merro will be here when she can. She's caught up in something, so let's blame Nacha. We'll just blame Nacha. It's his fault. We'll just blame him. I don't know.
It's always got to be someone's fault.
Yes. So we are excited because we've been trying to do this for 9,000 years, but we have almost a doctor with us. Yay.
Hello, everyone. So, yes, I have been meaning to be on here for a bit. We did mention this a while ago, and it does feel a bit like 9,000 years, but I like my history, so it's always good.
Well, why don't you tell everybody a little bit about yourself, what you do, where they can find you, that sort of thing.
All right, so as my name suggests, almost a doctor, although you can call me Matthew if that's easier. I am currently doing a PhD. I'm actually a physicist, and I'm working in building environmental monitoring gas detectors. So at the moment, we're working on methane detectors, and I utilize lasers in that, though I have done previous work in the field of lasers. I've worked on making new materials for lasers. So I kind of have this thing where I've done a little more of a focus on lasers in some of my other work. And on social media, I make YouTube videos. I also have a Twitter account if you want to get in contact with me that way and listen up for my latest information when I'm bringing out new videos. But I try and tackle interesting questions such as, do submarines fly? Can seals dance? And my latest one will be me looking at Bond cars to see how realistic they are. So that's a bit about me, and hopefully enough background for now.
Okay. So this particular show, what we do is we like to talk about actual science, and we also like to talk about bad science. So I wanted to first ask you, I don't know if you keep up with the US or anything. It's a hot mess here.
It's a bit hard not to.
Right? It's a hot mess here. We recently had a woman, a congresswoman, who said that there were space lasers made by Jewish people that causes wildfires.
I have heard of that. I'm not sure I could personally come up with something more ridiculous if I tried. And yeah, there is a lot wrong with that. If you're looking at lasers, space-based lasers are not a very good idea. There are a number of reasons for that. You're better just walking out there with a lighter rather than
Okay.
trying to start a fire with a laser.
So, how would that go? Why is it a just give me like 5 top science reasons why space lasers can't exist if you can't.
Well, they can exist. They're just a fairly poor idea in terms of using them as a weapon. And there's one main reason. So I'll try and get 5, but the main one is that lasers are incredibly inefficient, particularly as a weapon. They're very, very useful because they've got certain properties to them. But as a weapon, no. So if you want to get a certain amount of power out of a laser, there are theoretical limits to how much energy you have to put in. So if you want to start a fire with a laser, you're better off just taking your power supply in the first place and using that. So there are 3 components you need to a laser. You need a cavity, and I'll come back to that. You need a pump, which is just your energy supply, and you need your gain media, which is what you're actually getting your light out of. So when the light comes out of your gain media, your cavity bounces that light back and forward. You let it build up, and then you can pass it out of generally a mirror that's not fully reflective. That's one of the common ways of doing it. But there are a lot of different ways around that problem. So if you want to build a laser in space, you have a few problems. One, power supply, because you've got to carry it with you. And putting heavy things in space is not very easy. Also, lasers do diverge. So as the beam goes, it will spread out. You can focus on trying to make it a little better, but just because of quantum mechanics, because of, just physics in general, that laser beam will get wider. So if you're trying to fire a laser from space down to Earth, so low Earth orbit, you're looking at least 200 kilometers, you're not going to be able to focus that laser very well unless you pass it through another lens. But if you've got a lens that has to be several kilometers across, you're already in trouble. We've got Merro.
Merro's here. So let me let me see if I can get this going and where we go with gallery view. Okay, so now I have to screenshot, but everybody can still hear you. Please continue to talk.
Hello.
Yeah, so, Merro, just for context, I'm explaining why space lasers are not a good idea because of a particular recent event in US Congress.
Has it got something to do with anti-Semitism?
Yes. I'm just going through what lasers are, how they work, and why a space-based laser is a fairly ridiculous idea. One of my favorite examples of where people did try and use a space laser was back during the Reagan administration, during the SDI or the Star Wars program, where they tried to make a space-based laser powered by a nuclear blast. Because that was just how much energy you needed for an X-ray laser, because it gets harder the shorter wavelengths you go. X-rays are shorter than most shorter wavelengths than most lasers, which is also why red lasers are more common than blue lasers, because it's harder to make them. And it proved to be very, very difficult. Aiming the laser was very, very hard, and there's just a few treaties that don't allow nuclear weapons in space. But if you want to build a massive laser to start a fire on Earth, I can think of a million better things to do with those resources. So yes, as a summary, lasers are incredibly inefficient when it comes to weaponizing them. And the equipment for a laser big enough and powerful enough to then reach the ground and still still pump enough energy in to start a fire would be probably more than energy you'd need to get the actual laser into space in the first place. There's nothing.
So
easy
Jewish
about
lasers in space, fully debunked.
I think the sentence alone, Jewish lasers in space, debunks itself.
Why doesn't
It's
Mel
a
Brooks
self-debunking.
get on this? Mel Brooks could make a film called Jewish Lasers in Space, and it would be fine.
There is apparently a movie out there, I learnt this the other week, about Nazis living on the far side of the moon and then reinvading Earth.
Yes.
But I can't remember the name of it, but it doesn't look too
It's
serious.
something like Iron Fist or something like that. I had someone tell me it's one of the best B-grade movies I've ever seen. Like they downloaded it and watched it and said, "This is so amazing. I need to go and buy a physical copy." So they went and found it in like the $10 buckets, the $2 bucket somewhere. And they were like, "This is the best movie ever." And apparently I have to watch it. I still have to. I think it's Iron Fist or something.
Iron
Yes,
Fist.
I was
And
being told about
sorry-
that. I got to watch it.
Yeah. I also have to say I apologize to everyone. There was a mix up at work. So I was held back at work for sure.
No worries. We were just blaming Nacha. It's okay.
Yeah, it's fair enough. Like you can always blame him. He's always worth blaming.
Oh my goodness. So why don't you tell us a little bit about your work that you do? You detect gas with lasers?
Yes, so there's a number of different ways to figure out what is around you, and it's easy when there's a lot of it. But when there's less of it, things get harder. So the basics of what I do is spectroscopy, and spectroscopy is the utilization, the interaction between light and matter. So in other words, you shine light at something or you get light shining out of something and you can tell a lot about what's there. So the basis is a lot of elements. If you heat them up, they'll give off very unique wavelengths of lights. They'll have a unique color to them. And it also goes the other way. If you put light into something, there are very particular colors, particular wavelengths that will be absorbed. And if you want to figure out, say, what I do with methane is I want to figure out how much is there. I can shine a certain amount of light into my sample, whatever I want to look at, and not all of that light will come out the other end. And by looking at how much light goes missing, I can make a fairly accurate guess as to how much methane there is, because you can look at the probability of different concentrations will give you a certain amount of absorption. However, when you start looking for things that are in only parts per million concentration, the chance of actually having some light absorbed significantly drops. And
Limit
so
of detection.
Yeah, so what our work is in is developing small sensors that can still pick up those parts per million concentration. Now, one way, if you think about it as, oh, if I've got a few particles in my little gas chamber and I'm firing a laser through, then I'll just make the laser bounce around a few times in the chamber, because then it's traveling further, it's got a better chance of actually hitting something. And that was the first thing that the group I'm with did. But now we're looking to something else that's a bit different. Instead of looking at how much light doesn't come out, we actually try and make the gas sing. We actually make sound using a laser. So the laser, when you pump the gas molecules, so in our case methane, that energy has to go somewhere. And it generally goes to heat. Some of it will come back out as radiation if you get the wavelengths right, but a lot of it will come back out as heat. And so if you heat something in quickly enough, you'll also increase the pressure. So if you heat it, then stop heating it, then heat it and stop heating it, you'll increase the pressure, then it'll decrease, then increase and decrease. And if you do that certain frequency, you end up with a sound wave, because sound is all about the compression and expansion of gas molecules. So what you do is you get a tuning fork, except you do like a quartz one. You can find them in watches, and you put it in the middle. And you get that sound wave to match the same resonant frequency as your little tuning fork. So you get the gas to push on that tuning fork, and as it moves, because it's made of quartz, and quartz is very special, when you push on it, you can actually generate an electrical signal. You have some little metal plates on the side, and you can detect that signal. You can actually detect the sound wave that the laser is
cool.
creating in the gas. And there's a few advantages to that method in that you don't actually need these giant path lengths. You don't need to keep bouncing the light around. You can just raise your laser power up as high as you can get it, which is something you can't do if you're trying to look for that drop with regular kind of absorption spectroscopy. So what we're trying to do here is use that technique. It's been around for a few years now, kind of early 2000s it first came out. We're trying to do this and get these detectors small enough but also versatile enough that you could, say, put on a drone and map a wide area, such as a landfill. Because one of the problems with environmental monitoring, when they say, here's a landfill, this is how much methane comes off, this is how much CO2, how many greenhouse gases, at this stage, it's still a theoretical guess. We don't actually know from a lot of these facilities how much methane is being released into the atmosphere. And if you want to know what that's going to do to the environment, then you kind of want to know. So we're trying to make these light, fast detectors that you can get those maps with. We're not the only group working on it, but we have been doing it for a bit. So hopefully that covers most of it. I know it's a fairly difficult concept to get around.
That's cool.
If there's further questions, I'm happy to elaborate on anything.
So a question here for that. Given that gas disperses and it'll expand, particularly out of landfills, that would have to be a pretty low flying drone, wouldn't it, in order to get the largest possible or most accurate amount of gas coming off of a landfill?
Yeah, so this starts to go a bit beyond what my role in this research is. But then you do need quite accurate statistical maps. But you could probably do different heights to actually see how that disperses, having a look. So the idea is that you wouldn't just have the detector and see like, oh, we've got this much methane. You would map, you'd fly it over a really wide area. You'd take measurements all over the place. Then you would work backwards to see what that map is, and you'd build a 2D or a 3D model. And then, yeah, based on knowledge of dispersion, you can actually work backwards to figure out how much methane is coming out. It's not easy, but it would be a very useful thing to do. So at this stage, we're very, very
it's very early days.
Study. Yeah. Particularly last year with COVID and everything that went on, it kind of slowed the work down a bit. But we're getting there. We now have a roof that doesn't have a hole in it, which is a start.
Yeah,
yes, we ended up with a hole in our roof, and it was I'm in the basement. My lab is.
Well, that's okay. I got really excited when you started talking about spectroscopy because analytical chemistry. That is just that Raman, DLS. I mean, UV vis. Man, I got you.
That's, if anything, is my area of expertise. I'm still, I haven't even finished a PhD, and in science, I'm not an expert yet. No, nowhere near it. But if I was going to say anything was my forte, it would be spectroscopy. My honours project, which was 2 years ago, and for anyone pretty much anyone outside of Australia, an honours project is like a 1-year master's. It's a 1-year research project. And I did it in a very particular area of lasing called polariton lasing. And we used that. We used reflection spectroscopy, we used UV vis, we used emission spectroscopy. So reflection is where you make a cavity with 2 mirrors on either side, and you shine light into it. The light gets trapped between the 2 mirrors. And then based on that interaction, you can figure out all these interesting properties. So I got to use clean rooms where we would coat like nanometer thick layers of silver to make the tiniest, thinnest mirrors you would ever see. And so I had got to gear up. So I was quite used to wearing a mask and full on protective gear. But all of that is not to protect you, it's to protect the experiment from you. So,
there's a couple of questions in the chat.
Sure, let's have...
about the sun. Maybe, I think Duende says, could you bounce light off the sun?
Cool. Theoretically, yes, if you pick your wavelength correctly. Because you can bounce light off almost anything if the properties are right. It's a bit harder with the sun because it is so bright. And if you get the wavelength wrong, then the light will be absorbed. So one of the reasons we know what the sun is made of is because of spectroscopy. As I mentioned earlier, most elements and molecules will have very specific colors of light. When I say color, I also mean ones that we can't see. So infrared, UV, even not quite. By the time you start getting to microwave, it's a bit too long for elements. And so when we look at the sun, you get this nice broad kind of spectrum that's kind of very white looking. So when we look at the sun, we get a bit of all the colors, so it looks white. But there are bands missing. There are dark lines when you look at the spectroscopy, and that's where the light is being absorbed. However, if you didn't get one of those, you could theoretically bounce. I think you could bounce something off the sun. You could probably do it with radar, but it wouldn't be very easy. But I'd have to double check on that one. I'm very curious.
Apparently,
cool.
apparently the movie you were talking about was Iron Sky, by the way.
Someone was showing me the trailer for that, and it's just got like these giant space zeppelins, which is weird because the Nazis didn't use zeppelins. That was actually World War One, about 20 years out of date. But anyway, I don't think that's the biggest problem I saw with that movie.
You know, Flash Gordon, though. Flash Gordon from the 80s with Brian Blast. Gordon's alive! You know, come on, man. All the lasers in that film with Ming's. Have you guys seen that film? Flash Gordon?
I don't think I have, but I may have actually seen a clip of the lasers being used.
Yes.
I may have seen a brief bit. Yeah.
You have to watch that. So Ming the Merciless is about to get married to his 37th wife or whatever, and then he's going to kill her after the wedding night. And Flash Gordon's flying in, and they're like, okay, let's do the laser tribute. And so this entire, like, fortress starts shooting lasers out, and they all have to dodge it because, you know, lasers.
So
and it's blasting
from
through
the description
ships.
alone, I can think of a few problems with lasers. So one of the things that movies love to show with lasers is that you can see a beam that moves, and you can see it like tracing out. The Death Star's an amazing example of that trope, where you see the beams come together and then it goes forward. But lasers are made of photons. They travel at the speed of light. Have you ever tried dodging a flashlight? Have you tried dodging a laser pointer? You would not be able to dodge it. Your best bet would be have some kind of AI or equipment that predicts where they're going to fire the laser and try not to be there. But that is one reason lasers are good as anti-missile systems. So they don't make very good weapons. But if you want to heat an incoming missile and blow it up early, that is something the military does. So you get giant infrared lasers, infrared being a bit easier to make than a visible one. And so your incoming target, and then you fire it. But a fortress that uses lasers for defense, I would love to see whatever kind of weird nuclear power they've got to run that.
Or their electricity bill.
Yes. Well, if they were using like a grid for a city, they'd probably short it out to run lasers powerful enough to do that. That always gets me in movies. You see people with handheld lasers, and you just like the amount of energy it would take to run that. You're better off just using a gun. And gun will probably also do more damage as well, because a laser you can reflect it, and even if you're using metal and you actually want to get through that metal with a laser, you need a lot of energy. You can do it though. That's why they don't make mirrors, but you can make mirrors that aren't metal. So you can make mirrors that will perfectly reflect any incoming laser.
You must hate science fiction movies then.
It depends. If they don't take themselves too seriously, I'm a bit better with it. But that's why I think some of them, like I know Star Trek does it, and Star Wars kind of. They don't actually call them lasers; they call them blasters or phasers or something else. So, yeah, I can watch some, but I also like my history. So if I'm looking at sci-fi movies, I can sit there and spend the whole time just explaining why people have got things wrong. I'm a nerd. I'm happy with that.
Merro, a film for you that makes you nuts, that says it's like has all the wrong things for sciencey stuff.
What's mine?
Mm-hmm.
The Call.
Yes, I agree with you. I don't. I think the person had attended maybe year 6 science, so they had then forgotten the rest. Whoever wrote that.
Yes. For those of you who don't know what the core is, it's basically a movie where the core of the Earth gets stopped because they set some sort of nuclear bomb off, and to stop it from like spinning, and then I don't know. It was just like
then
when
they drill. They get this weird drilling machine and drill down to the core and try and get it spinning again using nuclear bombs.
Yeah.
Oh God.
There was a giant kind of like amethyst, like this big, and it was do you remember that?
Yeah, I remember that. I'm just like, wait, that's not how heat works. Are they like finding a giant, opening in the earth where you'd find crystals is not unreasonable, but once you get into the molten mantle of the earth, no. I think there's a lot of problems with that movie. And also, they have one scene where, because the Earth's magnetic field starts dying, because that's apparently the main issue with the core stopping spinning, although it's a bit more complicated than that, is that all these pigeons start flying into things, forgetting that pigeons can still see. And just because your compass disappears doesn't mean you fly into a wall. But they forget that as well. However, if you pause that scene, if anyone knows what I'm talking about, at the right point where the pigeons are breaking glass, you can actually see a fish that they threw at the glass to break it. Because it's grey, and with the blur of the movie, it kind of, you can't tell the difference between it and the pigeons. But yeah, so anyone who watches that movie again, the scene I'm talking about with the pigeons, have a look for that freeze frame. There's just this random salmon being thrown at the glass.
Oh my gosh.
I've tried, like, I can think of problems with most sci-fi movies, but yeah, that one has to be up there, the core. I mean, a lot of the typical kind of doomsday ones I have a lot of problems with. 2012, if anyone doesn't actually remember, their whole explanation for why the Earth is going to pieces is because the neutrinos are mutating. Don't worry, I'm not actually ruining the plot of the movie. It's you can get all this from ads. But yeah, neutrinos don't mutate because they're a fundamental particle, but also neutrinos are called neutrinos because they don't do anything. So somehow the one particle that is going to do the least, the hardest thing to detect because it does not interact with the Earth pretty much, is what they think is going to destroy the Earth. So yeah, that one gets me a bit.
I remember watching, I think it was like CSI Miami or something like that, and somebody brought an Ebola, or maybe it was Ebola disease into New York, and they were like freaking out, going, "Where is it? What's going on with it? Where do I find the source of it? And where's patient 0?" So they were doing all the epidemiology thing, and then they found patient 0 and they died and whatever. And then they're like, "All right, what about the next?" And they're like, "Oh, it's okay. I'll just die out in the population." And I'm just like, what?
I think a few people thought that's what would happen with COVID.
Yeah. It was just they're like, "Oh yeah, we don't have to worry about it now." Like, it was this massive plot line where it's a contagious disease, and now it's like, as soon as they found where the source was from, they're like, "Oh, okay, it's all right there."
What was that one called again?
I think
CSI.
I think it was CSI. I think maybe.
Okay, it's one of the TV shows.
Yeah.
For me, it was Prometheus, which was the alien film.
I've only seen a bit of it.
Oh my god!
I've heard it is a steaming pile of garbage.
It is horrible.
Yeah, I couldn't get through too much of it. Like, I don't mind graphic movies. I can deal with I don't like jump scares, so I won't watch a horror movie for jump scares. But if it's just because they've got ugly zombies or ugly aliens, I can deal with that. That doesn't work. But yeah, Prometheus was just like, it just was not fun.
No.
And a lot of these space movies forget a lot of problems about space travel. And also that Prometheus, so the Alien series, and also a lot of zombie films seem to forget how long it takes for diseases to spread through a body. Like zombie films where you become a zombie in like 10 seconds. It's like, no, it's not how that works. There was a zombie series. It's one of the Korean ones called, was it Kingdom? I think it's called. And their zombies are caused by worms. Which was interesting. Yeah. But they actually gave a bit more time. Like it would take a day or so before you became a zombie. Or you die, or like a couple of hours. Although it varies. It's a few minutes to like a day.
Wow. I hated Prometheus because, so I was more of a squishy bio person. So in my analytical chemistry stuff, we were like detecting breast cancer in exosomes using nanoparticles and various types of instrumentation. So I'm sitting in Prometheus going, these are the dumbest scientists on the planet. Nobody licks the spoon in the lab. Nobody does that. And when you get on a foreign planet, you don't take off your helmet. 'Cause microbes. Oh my God.
Yeah. And I know, I don't, like, when you see all these people and it's like, oh, I'm just going to take my helmet off. I'm going to take my gloves off from him. It's like, even if they're suspecting that there's disease, it's like, that's not what anyone does. That's not how it works.
And you let the android like rub all over the green slime. And then he's like, oh, it's gooey, guys. Look at all this. And then he goes and makes tea for everyone with his slime alien covered hands.
I haven't seen that bit, but
oh my God. I'm sitting here screaming at the film going, what are you doing? You know, I wasn't kicked out that day in the theater, but
yeah, there's not a lot of science fiction movies that I've been overly impressed with their science. There's a few that have done a slightly better job. I mean, I will give them artistic license. I'm happy to be like, look, you can exaggerate science because it'll make a more interesting movie. But when it's just like, when they have things that are just so obviously flawed, it's like, have you not spoken to a physicist? Some of the better examples I've seen in terms of following the science was The Martian and Interstellar. Apart from the ending of Interstellar, I won't actually say what happens, so there's no spoilers. But in that movie, the science advisor actually had a lot more sway with the director. And I think at one point said, you're going to follow the science or I'm out of here. And I think they said, yeah, okay, we will. So they actually did listen. So up until that last scene is fairly accurate from a scientific point of view. There is creative license about parts of it, but in terms of the actual the, like gravity effects being near black holes, interstellar space, they don't do a too bad a job. But I was in hospital when I saw that one, so I may not have been in my best of minds at that time. So
weren't two PhDs, like wasn't there 2 scientific papers published because of that movie?
Yeah, because they actually used very sophisticated simulation to model what the black hole looks like. So there is a black hole at one point in the movie. And yeah, I think that's where the papers come from, because the actual 3D design of it was done as scientifically as they could. So yeah, I think that's where the papers come from. And if you look at the photo, the photo from a couple of years ago now of the black hole, the very blurry one, that
it looks like
is very, very similar to how they have it in Interstellar, which is why that movie I will give a pass to, except the last scene.
I had a problem with the time dilation. That was a little bit too extreme near the black hole.
It depends where the event horizon is, because you can slow gravity a lot. I think, I probably would agree with you without knowing more about it.
I think it was something like every 7 minutes on the planet was like 10 years on the...
Yeah, which is... I don't think... I mean, you can get time dilation like that, but I don't think if you were away from the black hole it would occur. Generally speaking, your bigger problems with the black hole will be spaghettification, which is where gravity between your head and your feet is so different you get torn apart.
Yeah, that
Wonderful
sucks.
term. But the cool thing with a black hole is if you fall into a black hole, if it's a big enough one so the radiation doesn't kill you, you can actually see the universe go past you in fast forward. So you can actually see everything still occurring you because the light can still get in. So you fall into it. Everyone else will slowly see you freeze. So it'll look like you stop moving and then you'll fade into red. And then as you get red shifted, you'll go into the infrared and you'll be no longer visible. But you can still see out. So you'll be able to see everything go past. So if you wanted to get through the pandemic really quickly, just fall into a black hole. Disappear quickly.
Yeah. The thing that bugged me about that film was at the very beginning when they were like, all the scientists gave up and like, well, we're just going to pay for this 90 billion whatever thing, send it off into space, find another planet. And I'm like, nobody would ever do that. So, like, that's where I checked out. Like, they would continue to research hydroponics, something.
Yeah, but that's the thing with scientists is that generally speaking, whilst individuals might give up, the process of science doesn't. It keeps going because it knows there is more to learn. You don't get to a point where it's like, nah, it's all screwed. Like,
I know. That's where I checked out. I'm like, screw this. I'm done.
And I think if you put enough money into enough research into it, you could get desalination to a point where you probably would be able to feed enough people that it wouldn't be a disaster. I mean, yeah, you'd probably lose a few people in the meantime. But apparently, that's one thing that's ignored at the moment. We keep talking about there's a lot of potential disasters the media talks about. Quite in some cases, quite rightly so, with global warming, climate change, and then also drying up and water, perceived water problems in the future. But that doesn't mean that the scientists in the background aren't working on it. The advances in desalination, the advances in water processing and finding it for new places, that's still going on. The problem is that the general society is a bit slow, and it's not because of any individual's fault. It's just unfortunately how everything works, is that because it's not a problem, people don't see the need to put all the extra funds into it. And that was one of the reasons why they got a vaccine for COVID-19 so quickly, is that research has been going on, as was discussed in a live stream with on Nervardia's channel last week now, towards the end of last week.
Yeah.
Is that research has been going on for decades because we had SARS and MERS, and it was just a matter of getting funding and getting past the red tape. Yeah, I swear half of my work is figuring out why the equipment isn't working once I get that equipment.
Yeah.
So
one of the reasons why vaccines take so long to develop is not because of the technology. It's because they have to apply for funding and then wait around for 8 months to find out if they don't have funding, and then they have to reapply. And so vaccine trials, like vaccines themselves, would be a hell of a lot better if that funding was already there. Like, we probably would have a lot better funding for diseases that we don't have any vaccines for now, could have been here for years because of that delay in funding, like 2, 3, 4 years. But now with COVID-19, it's just like everybody needs to have it now. And
well,
that's.
Oh, I was just going to say, one of the cool things about the vaccine is because since they don't have to grow the actual virus, that cuts manufacturing time extremely, like that's a huge thing, because all they needed was the genetic code in order to produce the spike proteins. So your own body makes those spike proteins, but they don't cause you any kind of illness. Now, some people have allergic reactions, but those are rare. And so they started investigating a COVID-19 vaccine back in January. And within a few months, they were able to do human trials because there was no live virus. There was no deactivated virus. It was literally just little bubbles of messenger RNA that the cells could take up, make these proteins. They stick out. Oh, hey, making antibodies. So it cuts out a lot of the time where you have to worry about using a virus. So they were able to push that through, but none of major the major milestones needed for effective research, particularly for FDA regulation and CDC and all that, none of those there were no corners cut. There were no corners cut. This technology has been around with the messenger RNA. That's been around for probably 15 years. So it was already established, which is cool. Yay, science!
Yeah. Also, I've just noticed a few other questions. I think
Go for it.
Titan Uranus was asking a few slightly lighter
Giant
questions.
butthole.
We just
Yeah,
call him giant butthole. It's fine.
All right. Well, I know what to use next time. I was just being formal first. Okay, the first one, can I use a space laser to write my name on the moon? Now, you could potentially use a laser to write your name on something because if you get enough energy, you could burn it. You could potentially do some heat damage to the moon and write something on it. Although I'd wonder how much would get scattered. The problem is that if you're firing a laser from close to the Earth, even if it's in orbit, it's still probably going to be fairly far away from the moon. So you have that problem of divergence. So by the time your beam actually reaches the moon, it's quite wide. I don't know exactly how wide it'd be because there's a lot of factors that will go into that: wavelength, the actual laser itself. So you might have trouble actually getting any detail with it, and the amount of power you'd need, you might want to just build your own sun. You have a better chance. Second one, could IR lasers be used to heat clouds inducing rain? Well, you don't want to heat the clouds because if you heat the clouds, it's going to make it less likely to rain. You actually I think you want to cool them down so the water would condense out of it first. But I am not a meteorologist.
Well, I mean, that makes sense. They're in some kind of water droplet gas phase. You heat it up, they're just going to move around and no more clouds, I would think.
Yeah, your best bet is cloud seeding, probably, although humans aren't very good at it yet. The science is still fairly low, but there are countries that are experimenting with it, but that's the best way to form water droplets is you actually need a particle or a speck of dust or something for the water to actually form around, the water droplet to form around. So if you spray the cloud with like a dust or something, then you can get all those particulates forming and induce rain. They also thought they could use it on to work on a cyclone to see if that would help. Actually, I can't remember if it was a cyclone or hurricane because I can't remember exactly where it was. And they picked one that was in the middle of nowhere, so it wasn't going to hit anyone anyway. I sprayed all these chemicals over it, and then it changed direction and made landfall. So they've decided that wasn't a very good idea, so they haven't really done it for bigger storms since.
What about chemtrails? Will lasers get rid of chemtrails?
The Illuminati will shut us down.
I remember listening to solar sails, and what they were thinking of doing was sending out these tiny little probes towards Alpha Centauri, like an inch big and only a couple of grams heavy, and just throwing laser at them because they'll have the little solar sails, and they're going to throw lasers at them to get them to like 0.1 or 0.2 C. But the problem I had as soon as they said, we're going to use lasers to speed them up was divergence. Have you heard anything about that? Maybe using these little tiny mini probes that go very, very fast towards Alpha Centauri and just take lots of photos as they go past?
I have heard the idea of this. So the idea is that they deploy, most of the ones I've heard is they deploy a solar sail. The benefit of a laser, yes, you would have to deal with divergence. But there's also no resistance in space, no air resistance, almost no air resistance in space because there's almost no particles. Still a few because quantum mechanics likes to mess with our heads. But once you get it going, it won't take many photons to keep it going. So for anyone who's unsure how a laser could push something, photons, even though they don't weigh anything, still have momentum because relativity. So you can actually use light to push things. It's actually someone down in the lab downstairs who's trying to set up a demonstration with that. I've done it before where I've actually set up a tractor beam with lasers. I made a video on it if anyone wants to check that on my channel. You can hold particles with lasers because the photons have momentum. So the idea is that you fire a lot of them at this probe and it pushes it. Now, I guess the balancing thing here is, yes, you would get divergence, but once you've got it up to speed, maybe you only need a few photons to keep hitting it to keep it going that fast. A lot of people who've spent a lot more time than I have looked at it, but I think you would need to work on very, very advanced lasers to reduce that divergence. Here, because basically you'd think, oh, let's just make a laser that doesn't diverge, get perfect coherence, if anyone wants to look up the fancy word for it. But you can't do that. Quantum mechanics doesn't allow it. But you can get pretty close. And so there are ways you could reduce those artifacts. But yeah, divergence would be an issue, but it might be enough that you can push the probe out towards it. And if you've got a solar sail, it would increase your area a bit. That would help. So the idea is not too far-fetched. It's just, how you would, where that power is coming from. But it would be more efficient, I think, than trying to keep a power source on the craft.
Okay. Thank you.
I have to do some calculations for that divergence. But it depends. If you used a longer wavelength laser, such as an infrared one, it'll be less of a problem. So maybe you can write your name on the moon after all, if you get a sophisticated enough laser.
I don't think we've said hi to anybody in the chat. Normally we do that. So let me scroll back a little bit. Mr. Shadow Kitty was first. How you doing? Almost the doctors are here, guys. They said hi.
Hello.
Apparently I'm here.
Peter gonna go for it. Critical Cripple. Lil Wizard Bro said laser shark. No.
That was my comment from earlier. Just no.
Aunt Jer. She's listening, but away from keyboard. Who else we got? We got
Scientist
Giant
Mel.
Butthole.
She's here.
I am
Giant
here
Butthole.
today. Yeah, Giant Butthole's here. Sinister Porpoise.
Harmonica Man.
Tesla Ranger. J.I. Person. And then we said maybe Duende. I think that's like I'm sorry.
Maybe Duende.
Duende. Harmonica Man. How you doing? Smiling Game Master. Happy Sunday to you too. But it's Monday for the people who live in the country that's not real.
No. Tesla Ranger.
Paramo9 on Twitch. Oh, sorry. Go ahead, Merro.
Oh, no, I finished my sentence.
Oh, sorry. Stephen Hobbs. What's up? Dr. Hobbs. Teenage Mutant Ninja Turtles had a neutrino issue. Chad Hall. Who else? I think we're caught up.
Gary Priestley is here.
Gary Priestley. How you doing? We got them here. We try to say hi to everyone. I don't know if that's the Southern in me or what. Like, y'all, people are here.
And KCA Randy is here as well.
KCA Randy. What's up? Oh, my goodness. In Denmark, they suck at spreading chemtrails. Here, the average last span grown 3 months every year.
So if anyone does see someone trying to push chemtrails, one of the common things they do is they show commercial airlines with tanks in them. However, most of those photos are actually of just ballast tanks they use for simulating passengers moving around a plane so they can test it before the plane actually carries real people. So if you're ever looking at that, do a reverse Google image search. You'll probably just find them as just, this is what they do with water to test the plane. They can't actually spray chemicals.
Oh my
They're
god.
the closest thing we've ever had.
Sense.
Yes.
Sorry,
Why
what was
do you
that?
make sense, guys?
Oh no,
Both of you.
Someone's repeating. someone's repeating the laser sharks. No.
Okay. I want to delete that comment.
It will be in your
Hidden.
head forever.
Yes, it is. I hate.
But I did actually make a video on putting sharks on lasers. So if you love laser sharks that much, then you can go check that video out.
You're going to be so sick of explaining that by the time you're done. You're going to be like, I hate this question. If you ask me this question, you will be banned by the time.
That's why I made a video on it, because then I can just be like, no, just go look at the video. I've already explained it. Besides, you get a couple of cool visuals.
Yeah.
I have to ask you guys. Okay, so me being a chemist, people go, do you make like meth like Breaking Bad? So it's like, that's the question I get. So
I think all of us are chemists, aren't we?
Do what?
Yeah.
I think all of us are chemists here, because I do have a chemistry major as well.
There you go.
Yeah.
Yeah. So what are the questions that you guys get that you are so sick of hearing? Sharks and lasers, is that one? So.
Well, I can't. It's quite a fun question, so I don't mind it. But we were in second year taught how to make meth in chemistry, because the actual chemistry you need to make it is very simple. It's why it's such a problem. It's so easy to make. There's so many different ways to make it. So our lecturer was just like, here, we've actually taught you the chem you need to know. Then using that, this is how you make meth. But they were very clever about it, because they did that in a way of like, look how easy it is. This is why you need to be responsible. But also, if you know a bit about chemistry and you know a bit about how to make meth, you'll know that there's quite a few things that can go wrong. So yes, including catalysts that will just, if you get them oxygen into them while you're doing your reaction, will just spontaneously burst into flames. So yeah, not a safe thing to do.
Yeah, I got the same thing. I was like, "Oh, there you go. You know how to make meth now." And I'm like, "Yay!"
They never taught us that. Not in the U.S. But the first thing they told us when we were in grad school was, "Congratulations, you're now on an FBI watch list."
My friends make jokes that I'm on an ASIO watch list, which for anyone who's outside of Australia, ASIO is our equivalent of the CIA. It's our intelligence organization. But I've got a lot of jokes in the past, because I'm also half Lebanese, that I'm a half Lebanese with a chemistry major. So I've got to be a terrorist.
Yeah, clearly.
Of course.
It was annoying for a bit, and then after a while I found the best solution to that was when, if someone trying to mess with me that way, I would just start explaining to them how to make explosives, and that normally scared them enough that they would stop asking the question. Because chemistry is complicated, but some of these things are fairly basic.
Okay.
Yeah, I have stories from people in labs where they have tried to make explosives. Fortunately, I've never actually been in a lab where an explosion has occurred. I've ended up in hospital because of an lab accident, but that was very different. It wasn't because someone was being stupid.
So the next question. Worst lab mistake. Could have been an accident, could have been a thing. What do you think?
Don't think it's going to show on the camera. I don't think the detail will be high enough, but I actually have scars all over my right hand where I needed a skin graft for 3rd-degree chemical burns. That was the worst thing that's happened to me in a lab. I spilt what was essentially a chemical weapon, which if anyone's also regularly watched Merro's channel will have probably heard me talk about as well. But we were doing a chemical linker that was going to hold 2 fluorescent molecules together, and the little chain in the middle was a sulfur mustard, and I accidentally spilt some of it on my hand when a separating funnel, the cap on it, burst off backwards. It was an accident, and I went back and did calculations, figured out it was only about 200 milligrams that had spilt onto my hand, but it took 4 days to stop burning. That's one of the things about mustard chemicals, is that they get into your skin and they're painfully slow. At one point, the skin on my right hand looked like a glove with holes in it, because they just had blisters that were several centimeters across. And once they burst them and cleaned them in the hospital, the rest of the skin just slowly started dying. They gave me the green whistle just to examine my hand. Like that was by far the worst I've ever had in a lab.
Did you Michael Jackson it for a while with a single glove?
Yes. So I had bandages for a while. I was in like full-on bandages in the Australian summer, because this was beginning of January, which we get 40, 45 degree days, and I've got giant, like several centimeter thick bandages on my hand. I also had this hand, I had bandages, but I didn't have the skin graft because the chemical splashed and then soaked into my skin, and pretty much everything I touched in the next little while after the initial incident also got burnt. So because I must have wiped my face like that, this whole section, I'm so lucky this part of my face didn't scar, because otherwise I'd have a nice big mark there. That was oozing plasma for a few days. I still have marks on like sleeves and like where I would have moved sleeves on elbows, but most of it's faded. It's quite hard to tell now, but yeah, that stuff hurt. But if you want to learn a lot about how burns units work, then it was educational, and I came back and finished the project. But yeah, but that's very, very rare to have accidents like that in chemistry these days. The safety committee and the head of safety over in the School of Chemistry are very strict, because, well, it's kind of their job. Not the only accident. There are accidents that occur because, well, science. But for me, it was like, well, there's my contribution. I'll happily come back. And if this has to happen again, but I get somewhere, I make the world better, then so be it. But try and avoid making chemical weapons in the future. But yeah, they hurt.
The worst I've ever had was I picked up just a beaker thingy, and it basically just slipped out of my hand because I had the nitrile gloves, and those things are as slippery as all hell, and they just went swoop, and this beaker was filled with pH of 1 acid. And I splashed it on me. I was like, oh, okay. And then my lecturer was like, that's pH of 1. I was like, oh, fuck, get it off me. So I just ran and just stripped. And anyway, lost my favorite pair of jeans. I ended up throwing them out because, it was like, you can wash them, but they'll probably fall apart. And I was like, I'll just throw them out. Oh, God, they're my favorite jeans. So I was pretty upset about that.
Did you end up using the emergency shower then?
Yeah, I was just and like soaking and everything.
For anyone who's never been into a chemistry lab, or I think some biology labs would have them as well, what it is a giant ass shower head just connected to the cold water tap with this big handle with like a lever that just hangs down. And the idea is that if you get nasty chemicals on you, you run over it, you grab this thing and yank it down, and it just dumps water on you. But in the School of Chemistry over here, I don't know if it's the same for you, Merro, there's no drain in the floor, so it just floods the lab. But the idea is that you wash whatever chemical it is off.
Yeah. We don't have an off switch for ours, so if you pull it, it's going to empty the giant silo that's at the top of the
At least ours you can turn off, because we've got to test them frequently. So you have to, I think every week you need to test them in each lab, and then every month you do a flow test. So you actually count how fast they're flowing. I've had to do that a few times. So yeah, you like put a bucket under the, just do it. Because yeah, you can't do it into the floor. There's nowhere for the water to go. I've never had to use one in a class, fortunately. But yeah.
No, it's just nitrile gloves are the most friggin' dangerous things, because it's like they're just so slippery.
And a lot of chemicals go through them. So dichloromethane and chloroform will go straight through the nitrile gloves.
Yeah.
So if you're ever using it and you spill a bit on your hand, then about 30 seconds later, your hand starts feeling warm, and then it starts to feel like it's burning, because chloroform will actually burn your skin if it can't evaporate. So yeah, you don't want to inject yourself with chloroform. That is quite dangerous.
No.
But I do know someone who in a lab went up to someone else with a beaker of chloroform and went, "Does this smell like chloroform to you?" And his mate was silly enough to actually take a sniff.
Was he on the floor very long?
No, but he wasn't feeling very well. So luckily it wasn't enough to actually knock him out. But
Oh
yeah.
god.
So by the way, so when you're in a lab and someone has a beaker, don't sniff it. Just you do wafting from a distance if you have to.
Yeah. Wafting from it so you don't get a full
Actually,
face of dosage of chloroform.
That's actually something that I remembered about sci-fi movies that I have a problem with. Anybody wearing a lab coat out of a lab has never actually worked in a lab.
No.
Not with that lab coat anyway. And also the idea of a perfectly white lab coat is almost ridiculous, particularly if they're a chemist. I don't think I've ever owned a perfectly white lab coat because as soon as you go into the lab, you get stuff on it. I've had lab coats with pink and brown, all sorts of colors over them. Pink, like bright, strong, dark, like pinky purple colors from metal
Potassium
complexes.
permanganate. Yeah.
I think chromium complex I had on one of them. So not particularly dangerous, but yeah, nice big pink patch on one of them. But yeah, the only lab coat, or the joke is the only lab coat that's white in the lab is the professor's because it's not in there. So
Oh my gosh. That's
the
funny.
PhDs, the postdocs, and the other little underlings all have very filthy lab coats. You can get them laundered, but they still won't go back to being perfectly white.
No, they never are. When I worked in industry, we we had like a whole just row of lab coats, and that's where you would go to get the clean lab coats. And we wore scrubs, we had shoes that we wore in the lab, and then you had your shoes that you wore at home. But I worked with infectious stuff. Well, not me personally, but the company that I did. So I worked with modifying yeast to where it would express the different antigens that we would use for diagnostic testing. So I was just the only person in my lab. So, but still, yeah, all of those lab coats were just gross looking. They were just, and they still smelled awful even after cleaning. So just yeast does not go away, guys. Yeast smell
A lot of
is
things
terrible.
don't seem to go away. But yeah, so if there's anyone in a lab coat trying to look more professional on TV show or anywhere trying to sell you something, you know they actually don't know what they're talking about.
So the accident that I had, guys, I managed to set a lab on fire when I wasn't there. I think I told you this, Merro. Did I tell you that?
You probably did, but I can't remember.
You may
set
have
a
mentioned
lab
to me in like a private call once. So I think I've heard this. It's pretty impressive.
Yeah, so it was like so I was a graduate student, and it was when we were working on our breast cancer test where we were detecting exosomes with conjugated nanoparticles with antibodies associated with a specific type of cancer. And so I was coming up with the miniaturized device that we 3D printed, and I needed basically a coating on it. So when we went through and used our gold slides, we used gold coated slides that had DSP-G on it to where the exosomes would sit. But we wanted to be able to isolate individual samples to run it on a single slide. So I was using like wax, and, after a while I figured out silicone was the way to go. But I was still working with wax, and I thought I turned off the knob on the wax that I had melted to coat the bottom of my miniaturized device. And the burner, well, not the burner, but the hot plate had a faulty switch, and it set it to high and didn't turn it off. But there was no light. It was like a really old school hot plate. So what happened was I was on a tour at a cancer research hospital, and my lab mate calls me and goes, "You need to get back here right now." I'm like, "What was wrong?" "The lab's on fire." I'm like, "Oh my God, is everybody okay?" And they're like, "Yeah, we're fine." But they evacuated the whole building. We were in the middle of finals. So the entire building in the middle of finals was evacuated. And so my lab mates, they were trying to handle it. And so the fire is a wax fire in a beaker. They panicked and threw cold water on it. And so all it did was spread the fire across the lab bench. And then they thought, oh, the fire extinguisher. Okay. And so it set off all the alarms. They called the fire department. And then I had to drive back from the cancer hospital and go, hey guys, everybody okay? So, fun times.
So
Make certain you just don't worry about knobs. Just unplug the thing. Just unplug it.
yes, yeah, a lot of the hot plates you are not calibrated either, so you have no idea what temperature they're actually operating at. I definitely know people who've started fires, but that's my favorite, starting a fire in a lab story.
Yeah, fun times. Grad school. Oh, I think we have questions in the side chat. Let me see. Massive Butthole says, worst thing that happened to me was my final exam in chemistry lab. Let's just say I was the first to identify my compound. The fact that I took a huge sniff of a sulfur compound. Ew.
Thiols are pretty horrid. They're nasty. I worked with one in an undergrad lab once. I was doing just part of the lab, and I was doing an investigative bit, and they let me use it. I was using tiny amounts. Everything was in the fume hood, and they noticed there was a problem with the smell in the lab, that people could smell it walking past. I'm like, it's in the fume hood. What I had figured out from earlier is that some of the vacuum pumps that you use to run filtering sometimes accidentally vent back into the lab. So we actually had to rerun that back into the fume hood. But even then, I remember going over to the sink to wash glassware after I'd rinsed it in the fume hood. And people could still smell the thiol compound, but I didn't have anything that had it on there. And I realized that people meters away from me were smelling the trace amounts that were on my fingers. So if Giant Butthole got a very big whiff directly of this thing, I can imagine he was not very good place.
Well, isn't a thiol compound all you need is one molecule for the senses because to get to your brain? Because I vaguely remember during my inorganic chemistry they were actually talking about thiol compounds binding really strongly to the copper compound that we use as a way to make our brains go, ooh, that smells like something. I think all you need is like one molecule for your sense of smell to pick up. The
Quiz
sense,
time, guys. Harmonica Man asked me, what is your favorite chemical besides coffee? So I'm building it. Here we go. What is it?
Ethanol.
I discovered alcohol. Bare naked
Although that's in
ladies.
its high energy position at the moment.
Yeah, it is.
See, I know I'm talking to nerds when I can say that, and then they'll actually rearrange it so that it's in the lower energy configuration.
It's more like this. More like you will need this spaced out as far as possible.
But there we go. Yes, I built that in the lab before. I used to teach an experiment to first year students about chirality, which is optical rotation because of the way you put chemicals together. So I had to teach all those molly-mod kits. So it's like, look, here's ethanol.
There you go. What's this one called?
That's
ether.
Yeah,
Diethyl ether, the Batman molecule, because when you draw it out in organic, it kind of looks like a bat.
Dimethyl ether. Yeah, you got it.
yeah. I remember it because it's ether ore.
So when people say the ether doesn't exist, well, that ether exists.
It
Yeah.
does. It does.
I'm a big fan of indoles. Indoles are really interesting. If you've got anything that's blue, the chances are the blue coloring comes from an indole. Yeah. So
What about our
and
souls?
arseholes are great.
Unless you know them personally.
As long as you don't have to get too close, they're great.
Oh, we're getting like super nerdy. So Dynacat loves me. How you doing? I think my favorite chemical is cobalt chloride.
Why? Is it
Yeah.
pretty or?
I think that's that blue. They use that in the blue glass. Cobalt glass. I think that's probably it. Oh goodness. Let's see. How to make a water buffalo. Take 2 hydrogen buffaloes and merge it with an oxygen buffalo. And voila, J.I. Pearson. Oh, that's a dad joke. Let's see what else. I'm trying to see any other questions.
Do you have a favorite element?
Me or Mel?
Either or. Ether or.
I can't say because it depends what you want to do with it. I kind of love so many of them. It's why have all of them on my cup? Well, it's actually a bit outdated now because it doesn't name the ones beyond 110. I don't know if that's going to show up, but
Yeah.
No.
that's not going to focus
okay.
well. But it doesn't show the chemicals beyond 110, so you can tell. But I'm happy to have the older one, bit of history. But it depends what you want to do. There's a few that I wouldn't want to have, like lead or mercury, but they have their uses.
Thallium. Thallium is a good one if you want to kill people.
So there's arsenic. They reckon that maybe early life, some of it may have actually, the energy cycle was based off arsenic. There was some evidence discovered by the Australian synchrotron where they did X-ray diffraction on some like the biofilm fossils from Western Australia or somewhere in Australia. We've got very good old fossils here, even though we don't exist. And they think that maybe potentially it is a bit old, so I don't know if it's been refuted since that early energy cycles may have involved arsenic, which might make sense why arsenic messes so badly with our energy cycles. That's how it kills us, I think. I might be wrong. I'm not a biologist. My area is generally on the physical side of chemistry. But
I have to say my favorite element is surprise.
helium, I can't speak highly enough of it.
Tish.
I can do lame science jokes all day long.
Eventually they'll all be argon.
I know. I tell more good chemistry jokes, but I'm afraid I won't get a good reaction. But the problem is when I say ones like that, people tell me I should go barium.
Chemists are sexy, though. We do it on the table periodically. I'm not even sorry.
That was sodium funny. I slapped my knee on that one.
Oh, goodness.
I'm about to
do
rage
this all day. We're about to break Merro with lame jokes.
Sodium and chloride went to jail for assault.
You want to hear about sodium, bromine, and oxygen? Nah, bro.
Nah, bro.
I have the feeling we're going to lose you a lot of viewers if we keep this up.
Oxygen
hurts me.
Oh, sorry. Is that your thallium?
No, this is my
I can't see.
oh crap. Oh crap. Forgotten.
Bismuth?
Is that
Bismuth,
fool's
yes.
gold?
No, it's bismuth.
Bismuth. Oh, okay.
Yeah. I don't know how well you can see it.
Okay.
It's gorgeous. It is very much.
Oh,
I
so
absolutely
shiny.
adore this element. Did you know its solid is less dense than its liquid?
Ah, that's cool.
Yeah. And the fact that it makes these little crazy little, like, I can't, there's not enough light, but it's got these little, square thingies. Do you know why bismuth makes these this square formation?
I mean, that's a crystal structure.
Yeah, but why?
Well, their interactions, I guess, when they start to cool, they form that pattern. I don't know
I'd have to look into it.
structure that is.
One
if
of
it's
my close
face-centered,
friends
cubic.
is a solid state chemist. He does a lot with crystallography. He might know. I'll ask him next time I see him.
Yeah, it must be something like with the way that the element sort of, I don't know. I don't understand why it creates these crazy little things.
So I need your guys' help on helping me identify this thing that's on my desk, because it's shiny and it's gold, but it's not gold. So I don't know. I don't know what to call this.
It's Donald Trump.
It's Donald Trump. This is a new element called Donald Trump. A golden poop.
It's gold. It's gold. And
Donald
shit.
Dumpian.
You can put it on my head and you can call me rude things. I actually used this in a lecture recently for metric.
When were you talking about how shit the imperial system measurement system is? Because as long as you did, because metric is objectively better.
It is. But yeah, guys, I'm that instructor professor person. I use golden shit emojis to talk about metric.
Or imperial.
The best prop I've ever seen a lecturer use was the second year special relativity lecturer, who at the time was the head of physics, who used Teletubby dolls for his observers and an old Xerox box as the spaceship. So he would explain different frames of reference with Teletubby dolls. It was amazing. And he brought out a vacuum pump to show us that objects will fall at the same speed in a vacuum. They had two long tubes, hooked them up. And he asked everyone, he points to the pump and he goes, "What's this?" And at half the lecture theatre, it's a fairly small class, maybe 30, 40 in the room, just casually went, "Oh, it's a vacuum pump." And he's like, no, it's Nunu, the little vacuum from Teletubbies. He just brought a picture up on his screen that he had ready for that exact moment. Those were really good lectures. He was an amazing lecturer, but just the idea of learning relativity in the twin paradox from Teletubbies is just too good to pass up. And we're all just thinking, because he's an astronomer, that he must do his theory in his office. And he just sits there with the Teletubbies on his desk and he moves them around a bit, then he writes down a few equations that he moves. But he figured out that one of them, the eyes close when you lie it down in the lecture. So I just remember he's talking and then he lies it down. He's like, "Oh, the eyes closed," and he just spends about 30 seconds. That's my favorite prop.
Oh my god!
One of my favorite demos, though, from physics was the Rubens tube, where you can actually see sound, you can see music in fire. So I actually built one recently. Yeah, and that's on my channel if I'm allowed to.
Yeah, I saw that. That was really cool.
Yeah, cool. That's one of my favorite videos I've made so far. It was so cool to make because I got to build a giant flame tube and then push sound wave through it, and you can see the sound waves in the fire. It's amazing. So yeah, Rubens tubes are really, really awesome. But one of the other ones from chemistry that I like is I'm trying now to remember the exact chemical. Is it potassium? No, it's not potassium. Maybe it is, but it's an iodine compound. It's got I3, but I forget what the counter ion is. It's touch powder. If anyone wants to look it up. And it's called touch powder because you touch it and it goes bang. So I remember one professor put up a big protective screen. He had a couple of rings on the separated by about 10, 20 centimeters each. And then he gets a long pole with a tiny feather at the end, and he just goes from a distance. He's put headphones and everything and just taps the feather on it. And it's when they all set each other off. Another lecturer did it the following year. No headphones. He was much closer to it. He had a screen, but he didn't warn anyone in the front row, and he just goes tap, and nothing happened. Because it hadn't dried out. It won't go bang if it's wet. And that's how you get them into the rings, you get into position. And so he was telling us the next week what happened is he's like, yeah, it didn't go off because it wasn't dry enough or not much of it went off. But when I was wheeling the trolley out and all the economics students were filtering into the lecture theatre, I accidentally bumped the door. And it all went off in one go. And he said, those were some very frightened economics students.
That's awesome.
It's like, this is what you get for not... This is what you get for choosing economics. You don't get the explosions. You just
and the
get
thing is,
the
a bit of it got
depression.
on the floor, so when you walked over the floor, it was just like a crackling sound. So there's a bit of it everywhere. But I do like that. But physics first year had a lot of amazing demos, and then they just stopped doing it in second year because they're like, no, we've already got you now. Now you learn just how hard physics is.
Oh my gosh.
I've spent many a late night in the library with friends trying to figure out how to answer statistical mechanics questions or quantum mechanics.
Oh God. You know, there's a reason why I have so many action figures. I mean, so this is like the same background that my students see. So sometimes I will just pull stuff. I'm like, so we got Iron Man here. And he's explaining, ionic compounds. So how's he going to do that? I even have an enterprise. So I'll pull up all kinds of different things and use that, which makes it more fun. Oh my God, it makes it more fun. I don't know.
And then you have the doggo.
I
Nina.
do. Nina's gone at the moment. But yeah, the dog is nice. And so I was telling Matthew beforehand, I was like, I have a doggy cam for my students. So when we get past a point, and it's like, because I usually have like 3-hour classes once a week for each class, we take breaks. I'm like, hey guys, look at the dog for a while. Like the
I
dog
gotta go
picture.
pee.
Look at the doggy. Yay. Nina's proud of you. But it's weird. This whole online world of academia now. It's challenging.
I normally teach labs, so I demo labs just part-time. A lot of people do similar things here when they do their PhD. I think in America, actually, you do more teaching than you would here. But I like teaching first-year labs. It's what I enjoy doing. When you get people, you can teach them new stuff. But we had to do some online teaching for physical labs last year. And that was difficult because explaining to someone who's never set foot in a proper chemistry lab how to do something like use a separating funnel for a liquid extraction, if you don't understand what that means, that just exaggerates my point, is that it's difficult. You can show them simulation, everything, and then when you actually finally get them into the lab, they'll still look at it and have no idea what they're doing. And quite rightly so. It's very, very new stuff. A lot of it's not that intuitive at first.
It's been very challenging here, particularly when a lot of our curriculum in the lab portion, because my classes are lecture and lab together. So we'll have lecture and we'll go through stuff. Now I'm at a point to where I'm going, okay, they've got to be able to collect data and analyze it. How are they going to collect data on their phone or on their laptop? So it's been very interesting and challenging trying to overcome that, particularly where I teach, because it's like 70% of our students are poverty line. So we're trying to help them with education kind of better their lives. So say, hey guys, we gotta sit here and do all this other stuff. But I've found some really amazing resources online that have been very helpful, and I'll be happy to share them with you if you want them later. chemcollective.org, great. First year students, phet.colorado.edu, really good physicsy things as well as chemistry things. Really nice simulations. They break up the monotony of just looking at me talking the entire time. They're like, hey, let's look at this. How does the ideal gas law work? Let's pull that up. Look at this. Now, and you can actually do like measurements and have them manipulate the equation and take the different, measurements they get, crunch some numbers, and predict what like the pressure would be if they decrease the temperature. So it's pretty neat. So being able to do that at least makes it a little interesting. And they're able to play around with things and see how those variables interact with each other and then apply the math. So, because math scares everybody in the South. Oh my God. Everybody in the Southern US is terrified of math and science. All of them, except maybe 5 people in any given class.
And you're one of them.
I used to be. I used to be terrified of chemistry and math and physics. And then I was like, once I figured out how I learn, and I'm going, okay. And then somebody explained things to me in a way, I'm like, oh, I get it now. And then the math came later. So that's kind of how I teach. Concepts first, and then their interactions with each other, those variables, how they interact. And then I apply the mathematics to that much later on in my Chem 1 class at least. So it's a hard life, man. At least for my students. I don't know. How do you teach physics, man? How do you do it?
I mainly actually teach chemistry because I just enjoy the labs from Chemmel. Because we've done fairly well here in Australia, we were able to get some physical labs back. So what we did was just extreme social distance labs, one person to a bench, and they only do 2 instead of 9 experiments. And the idea was we don't focus on theory too much, just get them using some of the equipment. It's going to be apparently mixed this semester, so it'll be a similar thing the upcoming semester. But online, yeah, what we did, I'm not really in charge of actually the curriculum. I'm just one of the people. It's like, here you go, this is what you explain to them. What they did was set up a video where they actually got some of the staff to do the experiments. They got filmed doing them. They explained what they were doing. They showed the results. So they show them. And then we got the students to write a lab report like they'd been in there and done the experiment, and they showed results. Things like titration, absorption, so like Beer-Lambert law type stuff with sunscreen. So which ones are more effective? And then there was a few simulations that they'd found as well. So, but it's as I was saying earlier, it's just not a replacement for being there physically. But I think really the third year students, because there's less of them and the lab is still fairly big, they can get them in. And when I was teaching, they made everyone wear gloves. We couldn't force anyone to wear a mask, or we didn't, mainly because we didn't also have a big enough supply at the time. But again, like at most, we were getting a few cases a day in all of New South Wales, so it was a bit safer to do it, although a lot of people brought masks.
We actually had really good stringent protocols. You had to fill out a wellness checklist. Do you have a fever? Do you feel sick? Blah, 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 all that. And then you went to the front door of the building, and then you had to show that you filled out the wellness checklist. And then you got a mask, and they checked your temperature, and then you could go to the lab. But in my state, I actually did a socially distanced vacation the first week in December, getting a cabin in the mountains. And that county, come to find out, had the second highest rate of COVID-19 infections. And so when it started to get way out of control. We were doing hybrid classes where we would have 9 students in an entire lab room. But a lot of these experiments would require somebody to keep time and another person to actually work the apparatus. So there wasn't really effective social distancing. And a lot of my students got scared. And I'm like, well, I don't want anybody to be afraid for their health coming to class. So I'm just like, fine, we're just going to transition it all to back online again. But I wanted to show you. I know you probably can't see this so great, but this is chemcollective.org, and they have thermochemistry, kinetics, equilibrium. They have virtual labs, auto-graded problems, and it's, it's a nice little interface. So this is good for Gen Chem 1 and 2. Organic's not so great in this, and they have varying levels of difficulty. But I like this. So just go. You get an actual video. Okay, next. It's the HTML. But it's like a little workbench. It's, not nearly as exciting as a lab, but it's a nice, good exercise. This is a glucose dilution problem, but it hits a lot of the main concepts. So that might be something that is helpful to you in the future.
Thank you.
I will definitely keep that in mind.
It's all good. Oh, we're coming up on an hour and a half.
Yes, I was just seeing that.
So probably let you go soon so you can start your day, huh?
Yeah, although my next video comes out soon, and then, I'll probably need to have lunch.
Yeah, you'll need to have
it's
lunch.
12:30 here, and then, in my labs. But I was going to probably be at uni till late anyway, because if I don't leave before peak hour, getting home is not easy.
Yeah, you may as well stay in the lab until like 7 o'clock at night.
That's normally what I do.
But,
Or
lab's
at least in the office.
home.
But you'll find that because PhD students know they're going to be in the office for so many years, a lot of the people around here, because we get our own desk at least, kind of make their own desk like a second home almost. I've got supplies. I've got an entire drawer full of tea. I've got about a dozen containers of 2-minute noodles because I'm a student. I've got a bean bag as well.
Oh, goodness. Well, it's good to nap on one of those,
Yes. Just as long
Get a
as I
good
also
nap.
get my work done.
Well, we can wrap up here if you need to handle some things.
Yeah, unless there's any other questions, people, last quick questions anyone wants to answer?
Yeah, any other quick questions? Let me check. Jay Person says crystal structures are square or hexagonal because they want to be.
We let the crystals be whatever they want to be.
Yes.
That's true.
And you can often, with some elements, get them to form many different crystal types depending on the conditions which you form them, temperature, pressure,
Allotropes.
etc. Plutonium's an odd one. I think you can get almost all of the different crystal structures out of it, but you can get the least efficient packing one out of plutonium.
Yeah, isn't that Dr. Carl's favorite element is plutonium for that reason?
Maybe. I have
I
to
think
check.
so.
Don't know if I can. No, I can't remember. Sorry.
Yeah.
Oh my goodness. Big Butthole says you all need plants in your office.
My
Dude.
office doesn't get a lot of natural light, because this office, once upon a time, this building was built in the 20s, and this office didn't exist when the building was put in, and the floor I'm on didn't exist when the building was built. So the window at my side starts halfway down the wall and then goes all the way down through the next floor. So actually keeping plants that are going to get any natural sunlight is nearly impossible in here.
You can
maybe
mushrooms. Keep it in the dark and feed them shit.
There you go.
I think there's a few people that are that seem to be very much like mushrooms then. Although you could probably run it in my lab in the basement.
You might
The
could.
basement has more natural light than your actual office.
It has more artificial light anyway. Although you want to be careful with some of that light. It's laser light.
Oh, laser light.
You'll just have mutated plants will come and try and eat you in 10 years' time.
Attack of the
This
Killer
is not even
Tomatoes.
a biolab. How did they get mutated? I only hit them with a red laser.
If you guys want to watch a really bad movie, watch Attack of the Killer Tomatoes.
I've heard of
Attack
this
of the
one.
Killer Tomatoes. It's a B movie
Sounds
from the 70s.
Sounds interesting.
Really bad, really bad. Well, why don't you tell everybody where they can find you, Almost a Doctor, also known as Matthew?
Well, you can type Almost a Doctor into YouTube because I have a nice little YouTube channel and I do science there. So you pop Almost a Doctor. I also have a Twitter account. So like if you actually want to ask me questions, it's still a fairly small channel. So I will pretty much almost guarantee to get back to you. I tackle, as I said earlier, a lot of just different interesting questions. The Twitter handle is at Dr. Almost because Almost a Doctor was taken by someone. So yeah, so you can go at Dr. Almost or just type in Almost a Doctor. And the title is fairly self-explanatory. I'm doing a PhD and my goal is to hopefully one day become a doctor, just not a medical one. Don't ask me about biology.
Don't ask him about that. And his links are in the description, so you can
Thank you.
find him that way as well. Merro, do you have anything coming up?
This Thursday, my time, I'm going to have Telltale on my channel, and we are going to do a bite model breakdown of being American. Just wonder if America being an American is actually being in a cult. Personally, I don't think it is, and probably will come out that it's not. But there's a couple of things about America, especially American exceptionalism, that has a lot of cult-like things. So that's going to be interesting. I don't know if we're going to do the whole bite model breakdown or if we're just going to do the BNI, because these things can take quite a long time to break down. So yeah,
I've seen Telltale's videos. He does a very good job of it, so that should be interesting. If I'm available for that, I'll try and watch.
I do appreciate it. You're always popping up in my side chat, so I do appreciate you coming.
Often I'm working at the computer here, and that it's just like, oh, I could actually play the video on the side while I mess with this code or try and figure out why something's not working. I've been doing a lot of designing. That's why I've got parts in the office.
Oh, that's fun though. Building stuff is fun. I kind of miss that about grad school. Just like, oh, let me build this. My whole bench looked like a Tim Burton workshop with all the black different stuff that was dripping off of my 3D printed miniaturized devices. And I'm just
we do a lot of 3D printing. It's amazing for optics labs because when you need custom mounts and put things in specific places, the 3D printers for prototyping are really, really easy.
And if you're using fluorescence, black. Every single time. Don't use red. Don't use any other color. Black. If you're using fluorescence for any cells, because they all have a signature.
I did a bit of work in my honors with fluorescent chemicals where we would hit them with lasers, see what happens. So we had a whole bench set up to fire lasers. It was just a maze of lenses. It was like the biggest Lego set with glass that you'd ever seen. We had like 3 lasers, but about 10 different setups you could use on the bench just based on which mirrors you flipped into place. It's very cool.
Sometimes I miss doing research. I might bring that up at the college. We do have some undergrad research, but there's stuff I think I like. The pandemic makes everything difficult, but I'm like, there's stuff I can do. Let's do the stuff. I love doing the stuff.
Stuff is good.
Stuff and things, and then you write it down and you're like, look at the stuff and things I did, and then you make graphs. Nobody gets excited about graphs anymore, and that makes me sad.
I hate the writing. The writing is the part that I hate the most. Doing the experiment, fine. I just want to give my results to someone else and they can write up the report. Love
Oh,
it.
if only it works like that.
I know.
It does not work that
But
well.
it's all about the graphs. It's making those pretty pictures. That's what science is at the end of the day. Most of the time when I read a paper now, if I'm slightly familiar with the subject, I'll read the abstract, and then I'll just look through the figures.
Yep. And look
Because
at
that's
their
where
data.
most of the information is, those pretty pictures.
And look at their instruments. What's your detection limit?
Your N
I've got-
value.
Like I have papers on my desk, and that's what I'm after. These nice pretty pictures of how to work all my setups. See, pictures.
Not near
And they
enough
were all
highlighting
made-
though. You need some highlighters going through.
Yeah.
Yeah, you don't have highlighters. I'm disappointed.
Well, they're not stocking our storeroom very well at the moment.
Fair
Let's
enough.
see if I can.
Well,
I was,
thank you. Oh, sorry, Merro. Did you have something
I was
to add?
about to say I'll just send down some highlighters that I found from ages ago for you. Just give me your address. I'll just post them down. It's got Griffith University on it, just to make someone really angry. Where did you get this from? Oh.
I think a lot of universities give out stuff with their names on it, so
Yeah,
should be all good.
Oh my
it was
goodness.
just like traitor.
Well, it was awesome having you here, almost a doctor, aka Matthew. Please like, share, and subscribe. Check out his channel. He has really cool stuff. And follow him on Twitter. Follow Merro. You have to go watch her videos. And, there's not going to be a test, but you need to totally do that anyway.
Also, my next video, if anyone does want to stay around, comes out in 15 minutes. It'll premiere.
Go hop over
So-
there. 15 minutes. Watch his stuff, guys. Any last comments or thoughts before we sign off?
Watch Mel's Mel's stuff.
Yeah, watch my stuff.
Yeah.
Watch everybody's things. Here's a story of some science people sitting in our very pretty squares. Oh, Merro, what are we doing next time? I don't know.
I don't know.
I don't
There
know.
was that thread I showed you about the guy leaning, the leaning guy.
The leaning guy. We could do about the leaning thing. Okay.
Yeah.
All right. Well, I don't know what I'm doing Saturday, but hopefully a show. And you guys, if you have any suggestions, flood Merro's Twitter, message her all day, and then, we'll put together a show on what you want to do.
And also, if you want to do that, I'm fairly sure that sometimes there's communication breakdown between me and Mel, so you need to do that to Mel as well. So, yeah, flood her Twitter as well.
Yeah, flood mine amongst all the incels and the misogynists. You're not a true scientist. No.
No, how dare you have a brain?
Oh, God. Well, anyway, we're going to go and check out Almost a Doctor's video. So we'll see
Thank
guys
you.
next time.
Yep.
And thanks for having us on, Mel.
It was so much fun. You are free to come back anytime you want. If it's another 9,000 years, I'm sorry.
Well, maybe we'll have our space lasers by then.
That
Hopefully.
might be good. We'll have space lasers. Bye, guys.
Bye.